name of God, the most gracious, the most merciful. S2, the structure of agents, explained simply for class. Hi, everyone. Today, we're going to step into the world of agents in artificial intelligence. But don't worry, this isn't going to be technical or boring. I'm here to give you a clear, real-life picture of what agents are and how they work. S3. First of all, what is an agent? In AI, an agent is like a smart entity that can understand its environment using sensors and respond to it using actuators. Our goal in AI is to write a program that controls this behavior. This program runs on a piece of hardware called the agent's architecture. So we can say, agent equals architecture plus agent program. And what does the agent program do? It reacts to what it sees in the environment. Think of a robot vacuum. It looks under itself, checks if it's dirty, and if it is, it starts cleaning. If not, it keeps moving. Simple as that. S4, but how does an agent make decisions? Let's take an example. Imagine we have an agent that remembers all it has ever sensed and uses a giant table to decide what to do in each situation. This is called a table-driven agent. Nice idea in theory, but totally unrealistic in real life. Why? There are too many possible situations. The table would need billions of rows. For tasks like driving or playing chess, it just doesn't work. So we need agents that behave more intelligently, without needing everything written down ahead of time. S5, back to real life. Let's talk about ourselves. As humans, we don't always make perfectly logical decisions. For example, when we want a sandwich, we don't check security cameras or research the history of lettuce. We usually act based on familiar patterns. Let's explore some of these everyday patterns and how they show up in AI. 1. Instinctive behavior equals simple reflex agents. Sometimes we react without thinking. A loud sound? We shut our eyes. Hand near fire? We pull back instantly. These are built-in reactions, like pre-installed programs. In AI, this is a simple reflex agent. It reacts to the current situation only. Example, a self-driving car brakes as soon as it sees a car in front stop. 2. Model-based behavior equals model-based reflex agents. Sometimes we use past experience to decide. Example, you wake up with a mosquito bite. You don't need to see the mosquito. You just know what happened. When hungry, you don't overthink eating a sandwich. You already know how. In AI, this is a model-based reflex agent. It uses a model of the world to make smarter decisions. Example, a weather app that uses your location in a forecast model to say, it's going to rain today. 3. Goal-oriented behavior equals goal-based agents. Sometimes we act with a clear goal in mind. Example, a YouTuber wants to get famous. They'll do anything, climb a mountain, eat something weird. It's all about reaching the goal. In AI, this is a goal-based agent. It doesn't care about where it started, only how to reach the goal. Example, a self-driving car finds the best route to its destination. 4. Emotional but calculated equals utility-based agents. Sometimes we feel something and think logically. Example, you want to help a hungry child, but only have one piece of bread. So you give half. You help an elderly man cross the street, but only if you're not terribly late. In AI, this is a utility-based agent. It chooses the most useful or beneficial option. Example, a recommendation system like Netflix or Amazon picks what's most relevant to you. 5. Memory and story-based thinking is not equal to table-driven agents. Finally, let's be real, our brains don't store everything as a giant spreadsheet. Example, when you think of your grandmother, you recall feelings or stories, not a timeline of data. We think in stories, not in tables. In AI, old models like table-driven agents aren't practical. They don't think, they just look up answers from a giant table, which is limited and inefficient. S6, types of agents. From the simplest to the smartest. 1. Simple reflex agent. Only looks at the current perception, like a basic vacuum cleaner. Is it dirty here? Yes? Then suck. Acts very fast, but without memory, it struggles in complex or partially observable environments. Example, if it can't tell whether a red light is a brake light or just a tail light, it might brake when it shouldn't or not brake when it should. One solution, add some randomness to behavior. Occasionally take an action based on probability. This helps the agent explore the environment more effectively. S7. 2. Model-based reflex agent. A step up from the simple one. It doesn't just look at the present moment. It tries to guess the current state of the world, even if it can't see everything. For instance, a self-driving car may not see why a truck has stopped ahead, but it can guess there's a problem and apply the brakes. To do this, it needs two things. 1. Transition model, e.g., if I turn the steering wheel, where will the car go? 2. Sensor model, e.g., what am I seeing in the environment? Does that red light in the image mean brake lights? So this agent builds an internal model of the world. S8. 3. Goal-based agent. It's not enough to know what's going on. You also need to know what you want. Example, a car at an intersection doesn't know whether to go left, right, or straight. Without a destination, how can it decide? This agent uses its model of the environment plus a defined goal to decide the best path. Key feature, it can explain why it's doing something. If the goal changes, no need to redesign the whole agent. Just set a new goal. S9. 4. Utility-based agent. One step further. Suppose there are multiple ways to reach the goal. Which one is better? We evaluate based on speed, safety, cost, etc. This is where the concept of utility comes in. The agent aims to choose the action that gives it the highest expected happiness level. This is called maximizing expected utility. But it's not easy. The agent must predict the outcome of its actions. The calculations can be complex. Sometimes the utility function isn't even known. It must be learned. S10. Learning agents. Up to this point, we designed everything for the agent. But what if the agent could learn on its own? This idea dates back to Alan Turing in 1950. A learning agent has 4 key components. 1. Performance element. Actually performs the actions. 2. Learning element. Evaluates how well the agent is doing and improves it. 3. Critic. Gives feedback, e.g., well done, that was a good move. 4. Problem generator. Suggests new experiences for the agent to try. This structure allows the agent to go beyond repeating old actions. It gains new experiences and improves over time. S11. Environment representation. How agents perceive the world. To make decisions, agents need a model of their environment. This model can take one of 3 forms. 1. Atomic representation. Each state is a black box with no internal structure. It's simple but not very smart. S12. 2. Factor representation. Let's take a step beyond atomic representation and describe the environment with more detail. In factor representation, instead of labeling a state as just state 5 or state we describe it as a combination of features or variables. Simple example. Let's describe the state of a room. Instead of saying state number 3, we say, is the light on? True. Is the door closed? False. Is the window open? True. Each of these is a factor of the overall environment. This helps the agent understand what exactly has changed, analyze and respond more intelligently. Benefits: better understanding of the environment, smarter, more complex decisions, learns which factors affect which outcomes. S13. Structured representation. At a more advanced level, we enter the world of structured representation. In this model, the agent doesn't just see the environment as a list of features. It also understands the relationships between objects. This is exactly how we humans think. Human-style example. Ali has a book. The book is on the table. Ali is sitting behind the table. Here, we're reasoning with objects, Ali, book, table, and relations has on, behind. In this model, the agent can understand who owns what, where is something located, what happened or what might happen, where is this used. Natural language understanding like chatbots, scene analysis in images, complex planning, strategic and logic-based games. S14, final conclusion. In artificial intelligence, the goal is not just to build a machine that performs a single task. The goal is to create agents that behave rationally, meaning they make the best possible decision based on the available information. A truly intelligent agent should be able to perceive its environment, understand its goals, choose the best option, and continuously improve through learning. In other words, we're not trying to build a football team that just passes the ball. We're trying to build players who understand the game, learn from it, and win. S15, thank you. Thank you so much for your time and attention. I hope that AI Commander Alireza Kasabin, was able to shine a light, however small, on the vast and stormy sea of artificial intelligence and help guide you a little further along your scientific journey.